Let me get my controls. Let me just make sure I am well versed. Okay. Okay, so I'm Jacob Hicks, and this year in ISM, my first year of ISM, I'm studying biomedical engineering, which is the medical device field, prosthetics, life support systems, artificial organs, etc. A quick bit about me. I'll be attending Texas A&M in the fall of 2016. I plan on studying biomedical, mechanical, or petroleum engineering. I'm a member of the varsity golf team, and I'm the president of the FHS Orchestra. I'm also a member of NHS and the Climate Committee here at Frisco High School. And locally, I'm a member of the YMSL Frisco chapter. Outside of school, I'm a guitarist and a performing musician. I've been playing for almost 12 years, which is a long time. It's my most prized hobby, I'd say. I'm a diehard A&M fan and Cowboys fan, even though Travis doesn't like that. Okay, my mission statement this year in independent study mentorship is to gain knowledge regarding biomedical engineering and expose myself to the world and field of engineering in order to prepare myself for my future career. With my mentor's insight and knowledge, I plan to create a successful and innovative final product to display at the end of the year presentation. In the future, I hope to provide my country and the world with new technologies and innovations to give people improved quality of life and longevity. So basically, I want to learn more about the biomedical engineering field, and then with my mentor's help, I want to create a final product that helps the world and my country, even if it's through little triumphs. Just like Ronald Reagan said, we can't help everyone, but everyone can help someone. I might not help every single person in the world, but I want to at least make an impact on some people, because the little triumphs are what matters in the long run. Okay, my interviews. My first interview was with Mr. Eric Selke. Mr. Selke works for Spectral MD, which is a startup company in downtown Dallas that's headed by a very experienced mechanical engineer in the medical field and a heart surgeon from New York. Mr. Selke went to RPI, which is a big engineering school up in the Northeast, and he used to be a salesman at Zimmer and DJO Electronics, which are other medical device companies like Orthofix or Stryker. Important facts that Mr. Selke wanted me to know is that for a design team, they always need to be on the same page, and this is really important in the medical field because, like with antibiotics, drugs, prescription medicine, there's all these FDA regulations that you have to follow, and it's the same thing with medical engineering. There's 3 steps. There's like a risk 3, risk 2, and risk 1, and depending on what it is, it's higher risk. So, like a hip implant would be like a replacement hip. My bad. It would be high risk, and like a toothbrush is low risk. So Mr. Selke's company, Spectral MD, they're a startup company, and they're a niche product, and they produce a burn imaging unit. This is really cool. Most surgeons, when they go in for a burn treatment and like they're treating a burn victim, so if you have a burn on your arm, let's say just like tiger stripes, so you have like burned tissue here, healthy tissue here, you can't tell. Like a surgeon just has to like just kind of guess as of now. But with this new burn imaging unit, they take a little almost like an ultrasound, like when you're pregnant, and they can tell, like they can detect photons and like electric charge moving through the blood, and they know where the tissue's alive and where the tissue's dead, and that's how the surgeon knows to cut it away. That's pretty much it. That's Mr. Selke. My second interview was with Mr. Rob Snyder, who is actually a good friend of Ali Moretz. I didn't know that until we started talking. He graduated from UT with a bachelor's in business administration, and he originally wanted to be in banking. He was in banking until he was like 25. He interned all through college, but then he got into sales, and he ended up at Karl Storz Endoscopy, which is a medical device sales company, just like Stryker, Zimmer, the people Mr. Selke worked for. And but they specialize in endoscopes, and endoscopes are they're tools that you stick them in instead of like making a laceration, opening someone up. You stick them in through like certain pinpoints in the body, and you fill the body with air. You blow it up, and then you can work inside the body, and then do surgery without having to like cut someone open, which is really cool. It's also a lot better for brain tumors. You don't have to completely remove the skull, the top of the skull, like completely, and then do that again and again, like 8 times. And then you get all the tumor the first time. The endoscopes make that a lot more of a healthy process for the patient, and not so stressful on the human body. One of the recurring points that Mr. Snyder and my other interviewees pointed out is that the medical field is really relying on salesmen, especially the biomedical engineering field, because you have all these engineers working on these products, and they don't have the sales capability to make that pitch to the doctors. They don't have time either to go out and say, hey, buy our product. So that's why they have the salesmen. And the salesmen need to be well versed in that product. They need to know the product, know how it works. And one cool thing that Mr. Snyder pointed out to me was that these salesmen, they're salesmen like by day, but they'll go in during the week and they'll sit in these operating rooms almost over dummy bodies and do the surgery with the surgeon. I mean, they're not allowed to touch the patient. That's against regulation, but they can, if the surgeon is using a product which is newer, if they have a problem with it, the salesman is there to help them. So they're almost like fake doctors. Like they're almost like imitations of the actual doctor process in the operating room. Okay, my third interview is Miss Jessica Sampson, and she's going to be my mentor. I haven't heard from her directly, but Coach Goff has, so I'm really excited about that. I don't know why she hasn't emailed me yet, but that's okay. She attended University of Idaho and earned a master's in mechanical engineering. I want her to be my mentor because her current role at OrthoFix, which is a spinal implant and a corrections company, is because she works on the design floor as a manufacturing engineer, and she designs the machines that create the spinal implants and spinal screws, and she also designs the actual spinal implants and screws herself. She's not so much sales oriented, and she really knows her stuff. She stressed to me in the importance of knowing design software like Autodesk, and knowing how to dimension your designs in your sketches, and always knowing like what your team and your supervisors are striving for in that new product. So what she does basically as a manufacturing engineer is the machines that she builds, she's trying to optimize them. She's trying to make them produce the bone screws, the spinal implants, at the fastest, safest rate possible with the best quality. Okay, my fourth interview is Mr. Clint Walker. Out of all my interviewees, he was by far the most well-rounded. And the only reason I didn't pick him as my mentor is because his job is really high intensity and he's almost never in town. So he attended the University of Memphis and Duke, and he earned a master's in both biomedical and mechanical engineering. He's pretty smart. He went to school for like 15 years, so good for him. He originally worked at OrthoFix in a lead engineer role, and now he's in a hybrid position, which it reinstates that point of the salesman being very important in the biomedical engineering field, relaying information from the engineer back to the doctor and the hospitals. But now he's working in a hybrid position. He's almost an advisor to the sales reps and to the engineer, and he's like a middleman. And he has a very high intensity job, and he's never really around. That's why he's not going to be my mentor. But he had a lot to offer. He showed me a lot of the things he's made. He made a spinal like straightener thing, like a support. And the problem with the spinal supports, like for like recorrections, like scoliosis, sometimes they overcorrect. So he made it to like a certain degree where it's only going to correct towards back to straight up. And the biggest problem with those devices is that they'll correct you back to level, but then they start going the other way over time, and so then you have scoliosis in the other direction, and your spine's just out of whack the other way. Okay, my last interview was Mr. Chuck Schreiber. He graduated from Texas Tech with a master's in business arts, and he's a salesman at Ethicon, which is a medical device sector of Johnson & Johnson, which I'm sure all you know. It's a huge company. He's very similar to Mr. Snyder in that he sells bulk devices, but what he pointed out is that it's not on the slide. So what he pointed out is that you have all these products. So he has like 4,000 products, and he has to sell them to the hospitals. And the problem is that these hospitals are looking to save money, especially with like Obamacare and all that stuff that's come out. The money's tight, and you can't afford to buy like 10 of this one product for like this huge inflated price. So what these medical companies are doing, these medical device companies like Ethicon and Karl Storz, is they go in and they're like, okay, we'll sell you all this stuff in bulk, like 10,000 pieces, 10,000 products, and it'll be like a 30% decrease in price. So they're kind of cutting corners, but not really, and they're selling in bulk just like Costco or Sears would do to decrease the price overall in the long run. Okay, my career outlook in biomedical engineering is really good because the traversability in the field. I can be a biomedical engineer, I can get that degree, or I can get a mechanical engineering degree and take a couple of biology classes. But the thing is when you graduate with any engineering degree, you have the mobility to go to petroleum engineering, mechanical engineering, aerospace. You can do whatever you want as long as you get the basics of engineering, the physics, the math, the science behind it. So I think biomedical engineering, because of my love of biology, I think it's going to give me a lot of options in and out of college. This is a brand new biomedical engineering facility at Texas A&M. So basically, biomedical engineering is a marriage of biology and engineering, and that's what I want to do. I love engineering, but I have a knack for biology, and I like it just as more. That's Luke Skywalker's hand, so just for kicks. So biomedical engineering can be anywhere from cancer treatment to genetic engineering to prosthetics to artificial organs, and there's so many like individual parts of it that it's a huge field. I mean, it should be, because there's so many problems with people. There's so many health problems. There's infinite ways for it to be fixed. I mean, you can fix. There's so many options to make someone better. A big thing that I looked in also at the UNT, and I also looked into it at the UNT classes, is biomaterials and material engineering. Because a big problem with biomedical engineering is you make a product, and that product's chemical makeup, the material you're using, doesn't interact with the body in a positive manner. The body rejects it, and then your patient is in trouble. This is a big problem with artificial hearts. So in a heart transplant, what they do is they take the heart out, they put the artificial heart in for like 2 hours, and then they put the new heart that the person got back into the patient. And the problem is there are multiple cases where these artificial hearts, they worked on whatever they tested it on. They worked in the not reality phase, but the materials they made of, the polymers, the chemical makeup, the body rejected it, and then these people they die. So biomaterial engineering is really important, because you need to make sure that you're you have to make sure the polymers that you're using in your device are going to be accepted by all bodies, or you have to classify, this kind of person is going to take that and this kind of person isn't, because if someone's allergic to something, you're pretty much just killing them the moment you stick it inside their body. Okay, another thing I've looked at through my research is our biosensors, and this is more chemical engineering, but it's basically you stick a certain chemical, a certain molecule buildup into the body, and it goes through the bloodstream. And then you can track where it goes if you're trying to identify something wrong with the body, like a clot or something, and you can kind of see how it's working inside. It's engineering on the cellular level. I'm not really interested in that, but it's a cool thing to know. That's how far down biomedical engineering can go, all the way to the cellular level. Okay, key improvements that I'm looking at, but one of the things that really interests me about biomedical engineering is prosthetics and the bionics, the improvements in bionics and prosthetics. The latest rage, I'd say, is being able to make prosthetics feel. The problem is that we went from having a prosthetic that's just a piece of plastic strapped onto you, to a prosthetic that could kind of hold things, and then now we have prosthetics that are bionic and they can move. But the problem is that they have it to where it's connected to the nerves, but there aren't still nerves in the fingertips, so you can't hold these people with the non-able to feel prosthetics. They'll hold an egg and they don't know when stop squeezing to hold it, and the egg cracks. And the big thing is the biggest way that they're fixing this is through carbon engineering. They take carbon, which is you can make carbon into pretty much anything because it's organic. It's the organic compound of life, and what they do is it's a geometric design that's almost like little pyramids, and the pyramids are on the end of the prosthetic, and there are little pressure plates underneath each, and instead of wiring it into your arm nerves, they wire it into your chest nerves, because the arm nerves from where you had your arm amputated or it got blown off or whatever, those are damaged still, and they're not as receptive as the nerves that they are using now, which are in your chest. So they're wired into your chest right here, and then you can there's a little signal that's sent, and then your nerves know when to stop. It's pretty cool. So now these people with prosthetics, they know, like, to stop squeezing or to stop, putting force on something. They don't break things. It's a lot more like having a real hand. Okay, to wrap it up, I want to talk about my original work, which isn't on the prosthetic field, but it's a big problem. And Allie pointed this out to me because she's in mission work. A big problem with mission work is that the doctors that go down to South America and they go over to Africa, they have to take all this material with them, all this medicine, all these devices, all this life support stuff, surgery stuff, and it gets expensive and it gets cumbersome and it's really not convenient at all. So for my original work, I came up with a design that can fit all these devices, all these tools into 2 or 3 boxes and it's not going to be made out of like the same stuff that you find in the surgery room. It's not going to be made out of heavy metal, hard plastic. It's going to be more like light stuff, carbon fiber, that kind of stuff, just to make it easier for the surgeons who are using it to get it from point A to point B. So it essentially be a box that opens up almost like a traveling salesman, like in the movies, like they open it up and like you have like your makeup on this side and your mascara on the other side, or but it's going to be, instead of that, it's going to be like surgery tools, shots, and it'll be equipped with like a cooler for medicine, a cooler for medicine, and also a generator that can generate power. Not really sure how that's going to work yet. I would say solar panels, but solar panels are expensive, and the whole entire idea of this is trying to cut costs and increase efficiency. Okay, that's about it. Thanks for listening, and that's my speech about biomedical engineering.